were preparing for our trip to Rexburg, Idaho for the Eclipse, we came across an article about how communities in the path of totality were treating it as a disaster. Since millions, even tens of millions, will be flocking to a 70-mile wide strip across the nation. This disaster is expected to include cell towers, so we anticipate that making calls or using data will be very limited as we approach the path of totality. As a licensed amateur radio operator, I am able to keep loved ones in contact and have the ability to reach out in the event of an emergency. In addition to regular voice communication, I will use APRS, or the Automatic Packet Reporting System, to broadcast my position through a network of other amateur APRS stations. To build an APRS station, you need three things: a computer, a transceiver, and an interface in between. I wanted to build a highly portable APRS station, so I decided to use a Raspberry Pi as my computer. A Raspberry Pi is a full computer that is only the size of a deck of cards. It is a minimalistic computer that you can squeeze into very small places. It and the Arduino have revolutionized the maker movement. The best part about the Raspberry Pi, for a top-of-the-line model, it only costs $35. You can even get the stripped-down version, the first-generation Raspberry Pi Zero, for $5. The Pi comes with everything you need to run: HDMI for video out, USB for keyboard and mouse, onboard Wi-Fi and Bluetooth, and a micro SD slot as your hard drive. And it is powered by possibly the most common power source, a micro USB. The same plug that charges just about every non-Apple smartphone. It even has inputs for cameras and general purpose input-output, or GPIO, for running sensors, LEDs, motors, the list goes on. My favorite place to get my Raspberry Pis and accessories is Adafruit.com. Adafruit is a New York City-based company founded by Lemore Freed, a pink-haired Pierce electrical engineer from MIT, who goes by the moniker Lady Ada, drawing from Ada Lovelace, a mathematician from the 1800s who, among many other things, wrote the first algorithm for Charles Babbage's mechanical computer, the analytical machine. Check out Adafruit.com. You can spend many hours and dollars there, but I digress. So, a Raspberry Pi is usually loaded with a trimmed-down version of Linux called Raspbian. You can also put Android on it, but I haven't tried that yet. The operating software gets loaded onto a micro SD card, and you are ready to play. For my radio, I spent even less. I got this Chinese-made Baofeng UV5R on Amazon for $26. Now, you need an amateur radio or ham license to transmit on these frequencies, so if you don't have one already, and you're in the United States, go to the American Radio Relay League website, arrl.org, and click on the Licensing, Education, and Training tab to find classes and testing centers near you. To interface between the computer and the radio, you need something called a Terminal Node Controller, or TNC. I found one designed for the Raspberry Pi called the TNC Pi. You can find them at tnc-x.com. This was the most expensive part of the project, coming in at $65. If you're the adventurous type, you can order the unassembled kit for $40 and build and test it yourself. So let's get started. When you get your Pi, you will need to load the micro SD card with your operating system, and there's a little bit of work to do with that. First, you need to download an image of the Raspbian operating system. To do that, go to raspberrypi.org and click on the Downloads tab. Then, download Raspbian. Once that is done, you will need a way to put the image onto a micro SD card. Because a copy and paste won't work, you need a simple program called Win32 Disk Imager. A Google search will take us to a SourceForge for a free download. Install that, and you are ready to put Raspbian onto the micro SD card. So once you download the Raspbian image in a zip file, you need to unzip it or extract it. Now, Windows seems to have a problem with it, thinking that it's a 700 petabyte sized file, so just download a simple program called 7-zip, and that will allow you to extract it using 7-zip. So once you have the Raspbian image extracted and Win32 Disk Imager installed, you're ready to put Raspbian onto the micro SD card. In the Disk Imager software, select the Raspbian image, then select the disk allocation for your micro SD card. Now be careful selecting the correct disk. Writing a disk image will wipe anything that is on that disk, so you want to be certain you have picked the right one you want to use. If you accidentally select the C drive, you will wipe your computer hard drive and you won't have Windows anymore. And there is no undo button. So once you have the disk image source and the disk destination, click Write. It'll want to make sure that you're doing it right. Click Yes, and away it goes. Now you can put the micro SD card in your Pi and start computing. Now we need to set up Raspbian for our area for time, Wi-Fi protocol, and keyboard layout. Once you have your localization settings correctly, go ahead and log into your Wi-Fi or plug in a Ethernet cable into the Raspberry Pi. Next, we open up a terminal and we want to make sure that we have our Raspbian up to date for all of the software. So in the terminal, we type sudo, which gives us super user power for this command. apt-get is the command for downloading software, then update. Next, we want to input sudo apt-get dist-upgrade. Do you want to continue? Yes. Next, we need the software that will control the radio. I'm using Xastir, so we type sudo apt-get install Xastir. Do you want to continue? Yes, of course I do. But before we start using Xastir, there are some behind-the-scenes changes we need to make. These instructions are found in the Xastir manual. So first, we need to edit the /boot/command line.txt file. So we open a terminal. We type in sudo nano super for super user, nano to edit, and then the file name /boot/cmdline.txt. And that is a single long line of code. And we need to find console equals serial 0, 115200 and remove that. That's right there. Control X to exit, asking if we want to save. Yes. Save as what it says. Next, we need to edit the config file. So, same thing. Sudo nano /boot/config.txt. And we go all the way to the bottom. And we add enable _uart equals 1. And if you're using a Raspberry Pi 3, you also need to add in dt overlay equals pi 3 -miniuart -bt and core _freq FREQ equals 250. X to exit, yes to save, enter as the name, and now we reboot. Sudo reboot. Next, we need to edit or add, if it doesn't exist, to the /lib/systemd/system/hci attach.service file. And we add the following 3 sections of text. So what these sections of text are doing is that on the Raspberry Pi 3, the serial port can show up as TTY-SO, and what that does is it causes it to show up as TTY-AMAO, and the Bluetooth moves to TTY-SO so that the TNC can talk to the right port. Control X. Do you want to save? Yes. Save as that. Done. Once we're booted up, we go to run, type in Xastir. So in order to get the Raspberry Pi to talk to the TNC, we need to go into Interface, Interface Control, add a new interface, and this will be Serial Kiss TNC, add, and for the TNC port, we need to put /dev/ttyama0. Change the port settings to 19200 BPS. Click OK, and select and start. And there it is. So once we have the Raspberry Pi running Xastir, and Xastir is communicating to the TNC mounted on the header pins, and the TNC is connected to the radio through a cable, we can go into Interface and Transmit now, and listen on another radio tuned to the same frequency, and see what we get. And there we go. So to interface between the TNC and the radio, I bought a microphone extension, removed the microphone, and soldered a connector onto the wires that plugs into the TNC. That way I have a manufactured cable that connects the two. Since the TNC Pi was designed to be the same form factor as the Raspberry Pi, and it stacks on top of it, there were very few cases that would hold both boards. I did find one by Bud Industries. Just do a Google search for Bud Industries Pi case, and you will come up with this red clamshell two-piece. It fits both boards just fine. From there, we attach the radio interface to the TNC, to the radio. We plug in the GPS into the USB port. Now, since I plan to use this on a vehicle, I bought an external antenna. The antenna that comes with any handheld radio barely works because it's a compromise of an antenna. So the extended antenna with the mag mount. I also purchased a 12-volt car adapter for the battery of the radio. Remove the battery, put the adapter on. So with a cigarette lighter adapter that has USB output, I can run both the radio and the Raspberry Pi from one single outlet. To make it all portable, I have a 30 caliber ammo can that everything fits in, a few pieces of adhesive Velcro to hold everything in place, and all these devices fit inside the can. When I want to use it, remove the lid, plug it in, and it runs. Now, because I wanted the entire system to fit inside of an ammo can, I decided to run the Raspberry Pi what's called headless. That's without monitor, without keyboard, without mouse, which means I would need Xastir to start up every time I plug in the Raspberry Pi. In order to do that, I would have to modify the command lines, but there's something about the startup environment that would not allow Xastir to start up. So I finally found online somebody had the same problem, and in response somebody wrote a script that would start Xastir. After much digging, I found it in a Google Groups. I'll have that link below. It's too long to say out loud. But a big thank you to Keith Williamson, KF7DRV. Your script works awesome. Thank you so much. To find out more about the APRS system, go to the main website, aprs.fi. It's a Finland-based website. And if you're watching during the eclipse, you can look me up, AE7PJ, and see where I am as I travel to and from the eclipse location in Rexburg, Idaho. I hope you enjoyed this. I hope you tried the experiment yourself. Thank you. And now we reboot, sudo, not rebooty.